Okay, so in this next video we're going to be talking about displaying categorical data. So essentially I've recreated these examples at the top of the work example in the book, and essentially, so what we've done, this is strongly agree, agree, unsure, disagree, strongly disagree. So we've got four basic ways of displaying categorical data, because all we can really do is count how many things are in each category. So we can have a vertical bar chart or a horizontal bar chart, which are essentially the same. This is just, they're just twisted round versions. I suppose a horizontal bar chart might be better if you were maybe going to collect more data later and you were working your way along a page. But they are essentially the same type of graph. Now, notice we're calling them bar charts, and it's important to notice that there are gaps between the bars. And that is because these are separate categories of things. Once we get to numerical data and we do a similar type of graph, we'll be calling it a histogram, and the bars will touch each other, and that's usually because we're on a continuous scale rather than separate categories. But for now, when it's categorical data, the bars always have a little gap in between. So the other type of way we can display categorical data is a dot plot, and I want you just to sort of see how the shape of this, very, very similar to a vertical bar chart, and it's essentially the same. It shows us the same, once it's finished, that strongly agree and agree have both the most bits of data, and it sort of tails out this way. The advantage of a dot plot is you can create this I'm going to say on the fly, but as you go through each bit of data, as opposed to a bar chart where you would need to count all your data first and tally up how many things were in each category. With a dot plot, you can sort of do it as you go, which is going to be this example down here. And the other way we can display categorical data is a pie chart. That's a very poorly drawn one, but essentially it divides the full circle up into proportions. So strongly agree and agree should be the same number of degrees. Unsure is the next biggest one. Disagree is the next smallest one, and strongly disagree is the smallest. Sometimes pie charts the number that they would attach to each of these might be a percentage. It might be the actual number of bits of data. It's sort of optional. And I think the more you sort of get used to creating these types of graphs based on the data, it's fairly self-explanatory. Okay, so the first one I'm going to do is this V1.3. A group of students were asked to rate their level of agreement with the statement. I'm less honest on Facebook than I am in real life. And here is a little table of the responses, which is also in the book. And the question says, prepare a dot plot of the data. So I've created a little grid like this. I've put lines because the idea is we want to try and keep these rows of dots even as we go up, so that we get, if for instance, let's do it wrong, it says 3 dots, but if I were to space these ones like that, it might look like this has more data in it than that. So it's important that we try and keep a very regular. So I've just put those green lines on to help me keep count. So, as I said just a moment ago about doing these on the fly, what I'm going to do is I'm going to go down these columns of data, and I'm going to cross each one off, and as I do, I'm going to put a dot in my dot plot graph. So this is what we mean by data handling. It's kind of important to be very careful not to miss anything, be very methodical. Okay, so the first one, strongly agree, and I'm going to cross it out first with a dot. Strongly disagree, cross it out with a dot. Agree, I've got 2 agrees. I'm just going to put those in at the same time. 1, 2. Got a disagree. Unsure. Agree. Unsure. So you can sort of see how I'm building up something like this, and I'm being very careful that once I've represented each bit of data as a dot, it's being crossed out and doesn't get counted more than once and doesn't get missed. Unsure, strongly disagree, agree, unsure, agree, agree, disagree, strongly agree, and finally agree. Oh, just squeeze it in up there. So I think we can see that most students agree that they're less honest on Facebook. And so that way we didn't actually have to count how many things are in each category. We just represented each bit of data with a dot. And so doing it this way, we can sort of see that the majority of students, well, the greatest amount were in that group. The next biggest group was the unsure group. And then there was 3 that disagreed. Strongly agree, strongly disagree were kind of even. So that's how we do a dot plot. Be very careful, cross each thing off, represent it as a dot. Next one, dot. Next one, dot. And we can basically build this up as we go through the data. When we come to make a bar chart, you'll sort of see that we need to count each category first. This is the 1.4. A group of 50 business people were asked how you receive the news. The following frequency distribution table resulted, or a sectograph of the data. Okay, so we've got 5 categories. Newspaper, television, internet, radio, and other. And they're given, so this is the type of media, the category, and then we've got this word frequency. And we're not talking about what you tune your radio to. Frequency is once the data is collected and counted, the frequency just refers to how many things, how many bits of data are in each category. So we're given the numbers 15, 9, 16, 6, 4. And We're asked to draw a sector graph, that's another name for a pie chart, of the data. So we're going to have to do a little bit of maths. Now we're told at the start of the question that we're a group of total. If we were to add all these up, we should get 50 people in total. We're going to need that number. Okay, so let's just, how shall I do this? I've got a protractor, it's not a very good one, it's small, and I also have a ruler. So what I might do is draw just a rough circle. So the middle is about there. So we're going to turn this into a pie chart or a sector graph. But what we need to work out is how many degrees of the full circle do we assign to each of these frequencies. So we need to work out what proportion of the circle these need to be assigned. So because we've got 50 people, what we're going to do is use each of these numbers and make a fraction out of 50. So that will convert the frequency number into a decimal proportion, sort of like a percent. And then once we've done that, we need to multiply each of those proportions by the full amount of the degrees in the circle, and that should tell us how many degrees to assign to each category. So what I'm doing, this one, 15 over 50, and I'm timesing it by 360 degrees. 9 over 50. I'm just writing this out so that we can sort of see where these numbers come from. And when you're given a question like this, it's probably best to write everything out. Then we can find where the mistakes pop in. 4 out of 50 times 360. Before I even fill anything out on the circle, once I've calculated all these, because I want all of these things represented by the entire circle, once we work out these 5 numbers, this is going to be the amount of degrees. We should be able to add all these up, and it should add up to 360. Now, depending on how we round, it will be very close. Okay, the right mode. So I'm going 15 divided by 50, 0.3, 360. So this one, 108 degrees. 9 divided by 50. 360. 64.8 degrees. I think I'll manage to squeeze these in. 16 divided by 50, 0.32 times 3, 365. 115.2. So we'll round some of these decimals once we've got all 5 amounts. 6 divided by 50. 0.12, 2 degrees, and the last one is 60, 28.8 degrees. Okay, so I'm just going to round these to whole numbers. So let's call 64.8. We'll make that 65. Oops. 115.2. 15.2, we'll just make 115. 43.2, we'll just make 43. 28.8, we'll round to 29. So we had some 0.8s and some 0.2s. So now just to check before I even do anything here, I'm just going to add all these up and hopefully we'll get 360 degrees. 108 65 plus 115 plus 43 plus 29 equals 360. Fantastic. So now let's go on to actually creating the pie chart. So the first thing is I'm just going to put in a random line joining the center of the circle to the outside, and then I'm going to go in an anti-clockwise direction and just measure out these amounts of degrees. So the first one, put the middle of the protractor in the middle, and I'm measuring from here, so round to 90, that's 100 and 100, 110 is there, it's just before 110. I'm just going to put a little mark, move my protractor, and then use a ruler to connect that mark with the middle. And that is my newspaper proportion. Television is 65 degrees. So now I'm starting on that line, around this way 65, which is there. I'm trying to be as accurate as I can. TV. The next group, the internet, 115 degrees. We're measuring away from this line now. That's 90 under there. 100, 110, 115. It's there. Every time I move the ruler over the line, it gets a little bit off. The net. And then this little section is going to be split between radio and other. Next section we need 43 degrees, so I'm measuring from here this time. 10, 20, 30, 40, about there. So this is the radio. And if we just measure that last little section, it should be close to 29 degrees. And if I try and line it up, it's closer to 30, but that is just down to overall accuracy. Every time I mark this at 107 and this at 64 and this one at 42, or even just half a degree out, then we're going to be a little bit out. Other. So make sure when you make a pie chart, you always label each section. When you create these on Excel, they tend to just label them with a letter or a number. You need to tell it which one is which. Okay, so that's the process for creating a pie chart. So we essentially need to count up how many things are in each category, divide each of these separately by the total number of bits of data, that will tell you what proportion this is of all the data, and then to convert that to degrees, just multiply by 360. Okay, we've got one more example. Okay, so this is the last example dealing with displaying categorical data. So, just so that you understand what this means, here's the question. Members of a focus group were given 5 alternatives and were asked which word best described their feelings towards an advertisement they were shown. So, this is the data collected, and these letters, this is what they represent. So, O is off-putting, L is lackluster. That sort of means this was like hated it. This is didn't really like it. A is appealing, E is engaging, and X is exciting. So the first thing it wants us to do, tally the data on the frequency distribution table below. So that's sort of what I've got here. So unlike with the dot plot, the tallying, we go through each bit of data, and I'm going to cross it off as I go. L, so everywhere we've got lackluster, I'm going to put these letters L, X. So that's just like we're doing a tally, so that's where we sort of count 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So just, and this is just the process of counting how many of each response there are. So the next one, A, O, A, B, A. Very exciting, but you sort of have to be careful that you get every bit of data and you put it in the right category. We've got an X for exciting, off-putting, lackluster, appealing, lackluster, another appealing, so 5 of those now. 5 of them, appealing, and engaging. So that's just a tally. We didn't need all this space. So the frequency is just the actual number now that we've done the tally. So that would be 3, 5, 6, 3, 1. So tally the data on the frequency distribution table. That's what this is. So this is like the frequency. It sort of shows how the responses to these 5 categories were distributed across the options. Part B, what was the frequency of the reaction engaging? Well, here's engaging. There were 3 out of 3 out of 18 responses. Let's see, what was the relative frequency of engaging? Okay, so when we looked at the pie chart just previously, we actually had to work out the relative frequency in order to work out the degrees. So the frequency is just definitions. How many things in each category. Okay, so things may have just suddenly changed because the video cut out on me. So what I've done is, there is our frequency for each category. The question asks First of all, what's the frequency of the engaging reaction? And that's just a plain old 3, because that category comes up 3 times. What's the relative frequency of engaging? Now, relative frequency is, this is building up to a pie chart, but it is representing each bit of data as a fraction of the whole. So the frequency is just how many of each thing there are. And then the relative frequency is dividing those frequency totals by the total number if you added all those numbers up. What percent of the panel described it as engaging? So once we've got the relative frequency, so for this one, engaging, we'd have 3 divided by 18, which is 0.1. 18 is that, and then to turn it into a percent, we multiply by 100, just round it there. So the engaging category had 16.67% of the responses. And the last little section of this question says, represent this data in each of the 4 possible types of graph. So up here, I had previously done that. So this is our vertical bar chart. But then over the top of that, I've put red dots for a dot plot. So I kind of combined the two there because they are very, very similar. Horizontal, it's just the same information but going left to right instead of up and down. And the other type was the pie chart. So I've taken the relative frequency of each category, multiplied it by 360, and they just happen to nicely work out into full amounts of degrees. So I'm going to measure from here. So I remember, and I'm going in that direction. So the first one is 60 degrees. So that is, put an O there, put a dot in on my circle. So that's 60 degrees. Right. Then I need to add 100. 100 plus 60 is 160. And then I need to add 120, 160, 280. And this is only because I've got a protractor that goes all the way around. But this is totally possible. That's the L section, A section. Then from 280 plus another 60, 40. E, and of course leaves 20 degrees for the X. Now I'm going to take that off and try and drawing these lines without messing it up too much. Middle. part. And we'll leave one blank. Probably doesn't help. Maybe doing it different colours would have been better. But essentially, the important thing is being able to calculate how many degrees relate to each category. So we start with the frequency, divided by the total for the relative frequency, and then multiply that by 360 to turn it to degrees. Or multiply by 100 to turn it to a percent. Okay, let's leave that video there, and we'll see you in the next one.